All right, guys. So today we are going to talk about quadratics. Not the graphs so much and the functions, but the multiplication and the factoring. And that is something that a lot of people struggle with. So those are the different topics. I'm going to start with hopefully an easy one, and that's the multiplying. So in order to multiply, a lot of people say FOIL or distributing or something like that. But I always like to draw the boxes. Sometimes, well, when there's more terms, like maybe a 3 by 5 or something, I draw boxes even today. But when I'm teaching, I draw the boxes so that we can see what I'm doing. Okay, so what I did was I set up a little window, and the reason is there are 2 terms in the first one and 2 terms in the second one. So you can see we can put the first one across the top, and we can put the second one across the side. So I always do that, top side. Next, the reason why this is helpful is because in biology, you talk about Punnett squares. And so you're going to multiply the same way. We're going to multiply down, down, and across like that. So that's the idea. Okay, so for this box, I'm going to multiply 3b times b. And that gets me 3b squared. In this box, I'm going to multiply -4 times b, which is -4b. This, I'm going to do 3b times 2. So the 3 times the 2 is 6, and then b. So if we have a b times b, that's b squared. And then if you have numbers, you multiply them together like normal. And so we can see now here, -4 times 2 is -8. Then, so the first thing is set it up, top and side, right? Top, and then we multiply through. To fill in boxes. And now we combine the like terms. All right, so usually the like terms for binomials end up being here, but the like terms are the ones with the same variable and the same exponent on that variable. So 6b and -4b, those are like terms. And so 6 minus 4 is 2. So they combine to be 2b. So now the last step is to write all terms together. So as your final answer. So we got 3b squared. So that's going to go first because it has the highest exponent. And then plus 2b. And then this one has a negative sign in front of it. So I could put plus -8, but I'm just going to put -8. All right, so that's how you do that. I'm going to do those steps one more time with this. So I'm going to draw my little Punnett square here. And I'll put -4c plus 1, and then positive 4c plus 1. Notice I don't put the plus sign on the side. It's not needed. Okay, so 4c times -4c is -16c squared. 4c times 1 is 4c. -4c times 1 is -4c. And 1 times 1 is 1. And notice again, the like terms end up being on that diagonal. But this time, -4c plus 4c is 0. So my final answer is just these 2 boxes. So that first box, it's hard to read now, but it was -16c squared. And so now plus 1. So our final answer. All right. So now let's go on to factoring, which is backwards. And you see they even drew the boxes there. So basically they're asking us, oh, they gave us the side, right? And they're saying what goes on top? What goes there and what goes there? So 6 times what is 6x squared? Well, we already got the 6. We're missing the x squared. So if we put an x squared here, 6 times x squared is 6x squared. How about here? 6 times what is negative 18? 6 times 3 is 18, right? And if we didn't know that, you could always take the term inside the box and divide by what you know, because when you're trying to figure out multiplication, the opposite is division. So we can use inverse operations, and we would get negative 3. So it is negative 3. 6 times negative 3 is negative 18. All right, so the width is x squared minus 3. But factored form is 6 times x squared minus 3. So this, in factored form, is that. So we'll talk more about what factored form is. It's like the undistributing. So in the first assignment, I distributed in order to multiply. But now, whenever you see factoring, that's kind of like they gave you the answer to a multiplication problem, and you have to figure out what the problem was. What's the problem? So what we can do is we can draw our boxes and put in what we know. So if you look back at the first one, this first box was the term that had the exponent of 2. So I'm going to put x squared. See, because we have x squared, so I'm going to put that in the first box. The middle term in my first assignment, that came from combining the two like terms. So this middle term, that is the combination of these two boxes. So I'm going to have to figure out that one. But I do know the last term, this one right here, that was like that box, right? When I just multiplied the two numbers. Okay, so now after we set it up, so set up boxes, we put the x squared term and the constant term in. Okay, and now we are going to, well, I always like to figure out that x times x is x squared, right? So now we want to figure out what two numbers multiply to negative 4. And we also need them to combine to be 3. So they have to be the same numbers. They have to multiply. These two numbers have to multiply to be negative 4. But when we combine them, they have to be 3. We'll always start out with figuring out the multiplication. So what times what is 4? Well, it's either 2 times 2 or it's 4 times 1. So 2 plus 2 is 4. But 4 plus 1 is 5. But one of them has to be negative because it's not 4. It's negative 4. So 2 minus 2 is 0. So it's not going to be these 2's. But the 4 and the 1, now we can make that 3 if we make the 1 negative. So 4 times negative 1 is negative 4. And 4 plus negative 1 is 3. So that means we'll put a 4 here and a negative 1 here, or we could switch them. It wouldn't matter. Then I always like to multiply through to check. So this would be negative x. This would be 4x. And do they combine? Yes, they do. Check. Do they multiply? Yes, they do. Check. So that tells me that this thing factors into x plus 4 and x minus 1. X plus 4. All right. A lot of times people don't like to do the boxes. They like to just think in their head, what two numbers multiply to -4, and and those same two numbers have to add to 3. And we call that first coefficient A, the second coefficient B, the third coefficient C. So what two numbers multiply to C and add to B? You might hear that. So if you do that, that's absolutely fine. I can even do that with this one. So let's figure out what two numbers multiply to give us 18. 2 and 9. And then I just checked. 2 plus 9 is 11, so I'm done. So then I know that it's going to be x plus 2, x plus 9. You could do the same problem with the boxes, and you see I just basically took the most important step, did that, and so you can do that. All right. So now we're going to do some that are a little bit more tough, factoring with a common factor and factoring by grouping, and difference of squares is not tough, but it's weird if you don't know what you're doing. Okay, so factoring gets a little bit tricky when you have to look first for the common factor. So before you start factoring with the boxes, always look for a greatest common factor. What number can you divide all the terms by? If you look here, those are all multiples of 7. 28 and 35 are. So we're going to start by dividing everything. To make it more simple, we're going to divide everything by 7. So that means we can rewrite this as x squared plus 4x minus 5. See? So now we can ask ourselves, what numbers multiply to -5? And those same two numbers have to add to be 4. Okay, so that would be a 1 and a 5 are the only numbers that multiply to 5. And if I make the 1 negative, then it will work. They will fit both equations. So that means we can factor this like this with those two numbers. So x minus 1 and x plus 5. So that would have been really difficult if you didn't realize that you can divide everything by 7. But once you realize you can do that, then it's really, really simple. Okay, now sometimes you get something like this, and there is no greatest common factor because 17, you can't divide that by anything. So in Khan Academy, they'll show you how to factor it by grouping, and I could also show you how to factor it by grouping. But instead, I'm going to show you a method that I love called slide and divide. I've been teaching for a long time, but I didn't start teaching slide and divide until relatively recently, maybe 3 or 4 years ago. And I've found it's the easiest way to, and it works. So there's no reason not to do it. So what we're going to do is we're going to slide, and it's actually called slide factor divide. Okay. So when you learn how to do this, you'll be zipping through all your factoring problems while your classmates are getting stuck on ones like these. So what we're going to do is take the A coefficient and slide it to the end, because we don't want numbers in front of x squared. That makes it more difficult. So you can actually just slide it over. So now it's going to be 6 times 12. Okay. And then we're going to multiply. So 6 times 12 is 72. All right. So that was the slide. Now we're going to factor. So what two numbers multiply to 72? And those same two numbers have to add to 17. Well, I know my favorite two numbers to multiply 72 are 8 and 9. And guess what? 8 plus 9 is 17. So x plus 8, x plus 9. Okay, so slide factor. My students this past year kept forgetting to divide. Don't forget to divide. So what you divide by is whatever you had to slide. So we're going to divide by the 12. And so sometimes you can actually do division, but in this case, 8 divided by 12, that doesn't really divide, but we can reduce it. So if we divide them both by 4, then we get 2 over 3. So x plus 2/3. And 9 over 12, we divide them both by 3, we'd get 3 over 4. Okay, and you could, that's actually an answer that's perfectly acceptable, but I like to bump the denominator to in front of the x, so there's no fractions, and that is also correct. So this would be my final answer. 3x plus 2 times 4x plus 3. That's what I was saying. All right, slide factor divide. And the last one, so listen, difference of squares is super simple. And if you are doing all this factoring and your head is going in this direction, and then you get to something like this, you can be like, whoa, wait, what? So all you need to do is look at the terms. If they are perfect squares, then it's actually going to be really easy for you. All you got to do is take the square root. So the square root of 25x squared is 5x. The square root of 16 is 4. So we can write 5x minus 4, and we can, the second factor is 5x plus 4. And the reason that is true is because notice there's no middle term. So one being plus and one being minus cancels out the middle term. We can do the division and you'll see. Oh, let's just do the boxes, sorry. And you don't have to do the division. I'm actually done with the problem, but just to show you, this is 25x squared. This is negative 20x. This is positive 20x, and this is negative 16. So these two cancel out, and we're left with what we started with. So this factors into 5x minus 4 and 5x plus 4. All right, guys, have some fun and post any questions you have in our class organized worksheet.